All right, so yesterday we talked about polygons. We said a polygon is just a many-sided closed shape. So we're going to now talk about a very specific polygon, which is a quadrilateral, okay? We're going to talk about a family tree, and things might get weird. They will get weird within the family. So the first generation of this family tree is just any four-sided figure, okay? Any four-sided figure is called a quadrilateral. Now, the quadrilateral asexually reproduces and just has a baby, known as the parallelogram. There it is. There is, in the upcoming days, the parallelogram is going to reproduce and come up with some shapes. There's also going to be another kind of quadrilateral. And so then you'll see what happens. But these two would be, brother or sister or whatever. They're siblings. But for now, we're only going to talk about the parallelogram. Okay? We already know things about a parallelogram because we know things about parallel lines cut by a transversal. So imagine if I had two parallel lines cut by two transversals and the transversals were parallel to each other. That creates the parallelogram. So you should remember from the parallel lines lessons that these angles are the same and then these angles are the same. So imagine if you had another transversal that was parallel here. This would be the same, boom, 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 boom. So if I erased everything around this, we would get a parallelogram. And pretty much everything that you want to assume about a parallelogram is probably true. There are some specific differences when we talk about the diagonals, but for the most part, you would already have assumed that opposite angles are the same, opposite sides are the same, and so that's what we're going to talk about now. So if you have a parallelogram, the opposite sides are congruent. So RS is going to be congruent to, now be careful, R is an acute angle, so we're going to say that RS is congruent to PQ. Just like Q to R is congruent to S to P. And then obviously it's a parallelogram, so they are parallel to each other. If you have angles, the opposite angles are congruent based on this little diagram up here. So P is congruent to angle R and S is congruent to angle Q. Now, because it came from two parallel lines cut by transversals, you should remember that these kinds of angles, called consecutive interior or same side interior, were supplementary or totaled 180. And so when I make my parallelogram, these angles also are equal to 180. So a few quick problems. If this is 68, this angle is 68. We'll do it on the next one. The opposite sides are equal, so you're literally just going to set this equal to this. What plus 6 is 13, x equals 7. Same thing for the other one, opposite angles are congruent. Consecutive angles are supplementary, so 180 minus 123 is 57. And then we have to solve for the opposite side. So 2x minus 3 is 37, which means 2x's is 40, so x equals 20. Find the measure of ADC when DAB is 65. So once ADC, I'm just going to trace A to D to C. It's here. It's going to be the supplement of 65 for 115. Okay, so most of that was pretty self-explanatory. This is the part where there are some more rules, and it happens when you have diagonals, okay? So you need to imagine in a rectangle, which we'll talk about soon, everything is going to be the same. So these are the same length. But once you push this side out, this line becomes longer. And so in a parallelogram, these two lines are not equal to each other. So this one and this one are not equal. PR is a little bit longer in this picture than QS. However, they do bisect each other. So what that means is this is going to be longer. So let's pretend this is 10. So blue equals 10. And let's say QS is, I don't know, 8. They bisect each other. So then this would be 5 and 5 and 4 and 4. QM is congruent to SM, PM congruent to RM. And that's it. There's no special relationships in the angles. A lot of times people think that these diagonals bisect these angles. They do not. Let me just say that one more time. They do not. Since these are parallel to each other, this angle and this angle are congruent. This angle and this angle are congruent, and then this angle and this angle are congruent. Usually you can see that a little bit more easily if the parallelogram was like super stretched out. Let me use an actual line here. All right, that didn't work. Oh, go there. Come on. I'm not using a mouse. Okay, I'll just draw it. Come on. So you can see here, this is very, very tiny compared to this one. Same thing. If I drew that more accurately, this would be very, very tiny compared to this one. All right. So the diagonals intersect at point W, and it wants you to find the coordinates. Now, I know we're on a coordinate plane, so we could just count, but since they bisect each other, remember there's a formula we can use to find the middle point of a segment since it's bisected. Remember, it's the midpoint formula. So it doesn't matter what one you do. If you find the midpoint here from SU, S is at 0, 0, U is at, what is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Or you could do from T to V. T is at 1.5. Already, I probably wouldn't do this one. 5. V is at 1, 2, 3, 4.5. 0. So either way, I would probably just stick with this one. But midpoint, what do you do? Add them together and divide by 2. This is 6, 5 divided by 2, 3, 2.5. Or 1.5 and 4.5 is 6, 5. Hey, look, it's the same numbers. 3, 2.5. So you do not need to do this twice. Just pick your two favorite coordinates and find the midpoint. So same thing for this one. Find the midpoint of Z. Again, if you're on the coordinate plane, you can just count it. But if I just give you some random coordinates with no graph, you will have to find the midpoint. So this is 0, 0. This is 7, 6. So 0, 0, and 7, 6. Add them together. Divide by dose. 3.5, 3. Which is true. 1, 2, 3.5. 1, 2, 3. And this one's just a diagonal problem. It's a parallelogram. I want you to find MH. So this is what is 5. So MH would be 5. FH would be the entire thing. So that would be 10. And I think that's it. So pretty straightforward. Tomorrow we'll talk about the area of parallelograms, and then we'll move on to the next shape, hopefully on Friday.